Hello! This video is for Module 1 Part 1 and includes a discussion of the structure of data. Okay, let's go ahead and get started then. The first thing you're going to need to do is go to our course website at statsclass.org. There's going to be here, you can see the notes that are prepared, and also we have a video that you can watch as you're going through those notes. Before clicking on notes though, you're going to want to log into your account. You need to do that so that you can actually submit the information that's being requested in the notes. So let's do that first. I'll just log in using my account that I created. Go ahead and log in there. And now you can see I'm logged in. And when I click on my notes, you'll notice that you have a submit button at the top and the bottom of this set of notes. So if you don't see your submit my notes submit button here, that means you are not logged in. You need to go back, log in, and then click on those notes. That way, when you answer your questions, you're able to submit them for me. All right, so let's talk about the structure of data here. From kind of a higher up perspective, you can think of data as just information. So as a practicing data scientist, I often use those two terms interchangeably. It is true, though, that data have some features that typically is not required of information. So what do we mean by data? What we mean there is just pieces or bits of information or units of information. There are two simple features of data that can be used to separate data from information. So before getting into that, let's consider the following statement here. The sky is cloudy today. Okay, that sentence there, that statement, definitely contains information about the sky. It communicates that we're talking about today, and it also gives a description of the sky, which happens to be cloudy here. If this information is to be converted into data, we're going to want to do a couple of different things. We're probably going to want to know what we mean by today. So we'll probably record the date. And also, we're going to want to record the sky's condition. So in that statement, it happens to be cloudy. So if you can imagine a statement like this done over 5 consecutive days, the data that we obtain might look something like this that I have on the screen, where I have the date indicated for which day they're talking about, and then I also have the sky's condition listed here as cloudy, mostly sunny, etc. Generally speaking, the two things that define data, or data must have, is that data must be collectible. You must be able to obtain it. And the other thing is that it must be measurable. Okay, and when we use the word measurable, we don't mean that necessarily that it has to be, somebody's height, like myself. That's certainly something that's measurable, but just the sky's condition is measurable as well. Okay, the National Weather Service has definitions for what it means to be cloudy or what it means to be sunny. So we can say that the condition of the sky is indeed measurable, even though we're not using numbers to identify or measure those quantities. Okay, let's consider our first example here then. This information is about health insurance coverage in the United States. Okay, and this information is provided to us on a variety of states. So we can see Alabama, Arizona, Arkansas, all the way down here. So this data sheet has a bunch of rows in it, all the way down to Wyoming there. And when we think of data, this is kind of what we typically think about. There are, as I said, several states here, and then the information that's being collected here would be the population. This actually is in thousands. So if I add 3 zeros behind this number here, that's about 323 million people in the United States. That's the population here. I believe this data is from 2019, so it's a couple years old. And then we just have the number of people that are insured, the number of people that have private insurance, the number of people that have public insurance, and then also the number of people that do not have insurance. And if you want, you can click the data source here to see where this data was obtained. So when data is presented like this in a spreadsheet, we often refer to that as a table format or a tabular format. The table format is certainly the most common structure for data. Before any analyses are done, it is important for us to understand what kind of structure our data has, what the rows represent in our data, and what the columns represent in our data. So let's talk a little bit more about that. So when we use the term record, what we are typically referring to in tabular data is the rows. And a record is simply the unit to which information was collected on. If you are talking to a statistician might use the term observation for this quantity. A field or a feature is a characteristic that is being measured. So here, the features or the characteristics would be the state, whether or not the state has moved on to include Medicare expansion, the population, uninsured, private insurance, etc. Those are all different features that I measured here on these states. So the features or the fields simply represent the columns in a set of data. Again, if you're talking to a statistician might use the term variable there to indicate the different fields. So again, in this particular tabular format of the data, the records would represent the different states. I use that term a little loosely because the records include District of Columbia, which actually is not a state, and it also has a record for the United States, which is technically not a state. So what that means is we want to be careful when we're doing summaries on this data. So for example, if I wanted to obtain the total number of people that were uninsured, okay, in the United States, all right, I want to be careful not to include this row in the other rows if I was getting a total uninsured. I'm actually going to have twice as many people uninsured that I had intended because they have that United States as one of the records in this data. So we certainly, again, want to pay attention to what the records are. That determines what kind of analyses are appropriate and how we would conduct our analyses. As far as the fields, I already mentioned that. The fields, there's 8 in total here, and that just represents all the different columns that I have in my data frame or in my data set. So I might use that term data frame interchangeably there. What I mean by that is just the data table. That's the terminology that is used by software packages like Python and R. They call those data frames instead of tables. If I was considering a table like this in the SQL language, this would indeed be called a table here. So unfortunately, we have lots of different names for these things. We will try to stay consistent in this class by what we mean by records and fields. I've already talked a little bit about some of these comments. The second comment here, I guess I haven't hit that one yet. Sometimes fields are redundant. So for example, in this particular data set, we can notice that the age group is for all people, and that's the case for all of the states. So I don't really get any information by having this field in my data frame. I mean, it does tell me, I guess, that it's for all people, but it doesn't help me differentiate between the different states at all. On the other hand, Medicare expansion, that is important because some states have adopted that Medicare expansion and others have not. So if I wanted to do something like compare the uninsured rates across those that have adopted or not adopted the Medicare expansion, I would need that information included. All right, let's consider a different type of data. And here I just have a fictitious situation which I am collecting information about diabetes. And in particular, I'm talking about charting, okay, or individuals that are doing charting. And I've asked them to enter information about, okay, what was communicated to the patient. So this data here is very text-oriented. I do have a patient ID, so I know who each of these people are. But my data actually consists of just these statements here. I've only shown 2 here, but typically, right, in a study, I would have maybe hundreds of these. This is certainly data. Okay, this here would be patient ID. I would have 2 fields here, patient ID and then their description. The records would be each of the individual patients here. Okay, so this data looks a little different. One thing we might do with data of this type is we might create a word cloud. And a word cloud is simply just a visual summary of the most frequent words used in a collection of text. So here, if I'm reading through these, I can see that diabetic here has been identified. Diabetic has been identified again in this text box as well. So if this study is about diabetes, I would expect that diabetic or diabetes would show up a lot in these text boxes when we're doing our charting for this study. And indeed, that's the case. So the bigger the word here in this word cloud, the more frequently that shows up in that collection of text. Okay, so my question is for you, is this information or is this data? Personally, I would consider this to be information and not to be data. Okay, data has to be measurable. All right, and I'm not sure how to measure. Okay, what do we mean by measurable when I'm looking at this word cloud? Now you might say, well, it's not any different than what I have here. How is this measurable? Well, what I've done to create this word cloud again is to run through all of the words in this collection of text and identified how frequently that word was used. So in that sense, I measured that information. The information that I measured was simply a count of how often diabetic showed up or how often glucose showed up. So I definitely took this information that I have in these text boxes, converted that to data, and then I created some visual word cloud for you to digest that data. But I wouldn't consider this to be data. We do have this idea of raw data, and that is simply used to indicate that data is at its most basic level. So in this situation, the raw data would be the text included in each of those text boxes. Kind of an intermediate step would be what I discussed there, in that I would identify each word that was used in that collection of text and measure the frequency of use. That'd be kind of an intermediate step of my data processing. The final step here, again, happens to be just a display of a visual word cloud. Okay, how about a third example of data? So here I have some scans. Okay, we're looking at brain cancer. Historically, scans are read by doctors or others to determine whether or not brain cancer is present. In more recent times, though, we have started to use artificial intelligence to help us identify whether or not cancer is present in these scans. So what does the data look like that I would get from something like this? So the scan itself is a picture. And again, I just want to be able to identify whether or not cancer is present. The raw data that I would get out from these machines that do these scans may look something like this here. So this is just an example of output obtained from these types of machines. Now this data here certainly is not in a tabular format. It's actually what's called a JSON format. The JSON format is certainly more flexible than the tabular structure that we have up above. So let's just look at this a little bit to try to digest what kind of raw information is available to me here in this JSON structure. So this is data just from one patient, and the information for this patient is contained within these curly brackets. So these curly brackets here will identify a record for me. So here a record would just be the information from a single patient. So next let's look at the information here in box 1. Okay, that information is a field. And the field name is going to be body part examined. So what body part was examined? That's going to be the field name. So that might be, if I were to convert this into a tabular format, that might be the name of the column for that information. Now the value for that particular field is head. So these were head scans. So this was a head area that was examined. Another field that's contained in this data is the magnetic field strength. We can see that that has a value of 3. Or down here in the last box, inversion time would be another field. You can see here that the semicolon is being used to differentiate the field name from the field value. A comma is being used to separate the different fields. So here you can see at the end of each of these rows is a comma. That is separating that modality field from the receive coil name field. Now I mentioned that the JSON data structure is more flexible, and we can see that when we're considering the pixel spacing field. The pixel spacing field actually includes 1, 2, 3, 4 rows. Notice the comma doesn't come till down here. And what the pixel spacing actually has is 2 values. Well, it has 2 bits of information, but it has 2 values here. And these square brackets, not curly square brackets, but regular square brackets there, are being used to encompass those 2 values for pixel spacing. So, as I said a moment ago, the JSON data format is certainly more flexible and more complicated, but it allows us to keep very careful track of our fields, our field names, our field values, our records, etc. So even though this kind of looks like a mess, to me, this information here is highly structured. And I would be able to, with a little work, be able to turn this into a tabular format, which is a format that you might be more comfortable with. Okay, some questions for you then. So I would like you to answer the following questions down below. This here is just that same information about healthcare coverage, except that the age group now contains more than just all people. So this information is obtained for people under 65, 65 and over, and then under 19. So like how many kids are uninsured, you could get that information there. And I have a couple of questions that I want you to answer there. So how would a record be defined? And how many fields would I have here? If you want to pause the video now, you can and answer these questions, or you can answer these questions after you watch the video. Remember, after you hit submit, you can go back in and check your answers to make sure that you understand the content being presented here. In fact, if you want, you don't have to, but if you want, you can correct your answers. I think I mentioned this when I talked about the syllabus, but you're going to get full credit for just attempting to answer these. So there's no need to go back and correct your answers, but if you want to, you certainly can. A quick comment about the data here. These different outcomes for the age group, we actually call those levels. Okay, so I have what, 1, 2, 3, 4, 5 different levels for age group. And those get repeated for each of the states here. So levels are just the unique or distinct outcomes for a particular variable of this type. Medicare expansion is either going to be not adopted or adopted, so that only has 2 levels. Finally, there's 2 more questions, down here in the bottom. I just created 3 silly objects and wanted you to be able to identify what a record would be in this situation or what possible fields would be in this situation. Okay, so don't forget to submit your answers for those 4 questions. Make sure and click Submit Your Notes. When you do that, so if I just put some stuff in here, I just want to show you this. But once you submit your notes, you should get a little green checkbox back here that says that your notes have been successfully submitted. Okay, that does it then for Module 1, Part 1. Thank you and have a good evening.